Well, we have studied kinematics so far. Now let's get into dynamics. Dynamics studies the relation between motion, forces, and mass. We have talked about motion of point particles so far. So we have studied the how about motion. Now we're going to study the why about motion. Who makes the objects move and why they move the way they move. Now we have to talk about forces, about who is changing the motion of the object. So we're going to talk about forces which are responsible for the objects to change their motion. In nature, there are four different forces. There's the gravitational force, the electromagnetic force, the strong nuclear force, and the weak nuclear force. We will study the gravitational force in a few days, talking about gravitational attraction between objects that have mass. The electromagnetic force is due to electrical charges, and that we're not going to cover that in this course, but you can take any electricity and magnetism courses to delve into this interesting force. The two nuclear forces, which their range is really small, so they can only reach to distances about the size of the nucleus of the atom. You need to take atomic and nuclear physics or quantum mechanics or elementary particles to go into the details to understand that, and we are not going to cover that here. But for this chapter, for this unit, now we're going to talk about forces without thinking about what is the region of that force, what if it's nuclear or electromagnetic or gravitational. We are going to be talking about ordinary objects, about daily life situations. So a force is a push or a pull, and the forces act on objects. So we have an object like the mag, and we can apply a force on that object, and that force is going to affect the motion of that object. It's going to change the motion of that object. So the forces require an agent to exert it. For example, in this case, it's my finger that is pushing the mag. So my finger will be the agent that is acting a force on the mag. And we are going to study what's the relationship between the forces applied onto an object and how that object changes its motion. In order to represent forces, we will use vectors, which they describe a magnitude and a direction. And we will be talking about forces in 2D or 3D. And that's why we need to take into consideration all the components of the vector of the force. We will indicate that the magnitude is a vector by placing a small arrow on top of the letter. For example, V arrow, that means that that's the vector V, and that vector, for example, in 2D can have two components, the component X, Vx, and the component Y, Vy. And we can write it as Vx I arrow, where this I arrow corresponds to the unitary vector in the X direction, so the magnitude is going to be 1 and it's pointing in the X direction, and Vy is going to be the Y component, the component in the vertical direction, and this J arrow is the vector, the unit vector right at that vertical direction. The net force is the sum of all the forces, and the effect on the object is the same from just one force equal to the net forces as from all the forces acting on that object that they sum up to exactly the net force. So we will always work with the net force, but in order to get the net force we need to know all of the forces in order to sum them and calculate what is the net force acting on the object. If the net force is 0, the object will be in equilibrium. That means that it will be either at rest or with constant velocity, linear motion. If the net force is not 0, then we will have a motion which is different from that, and that's something we will study in the next class. In the absence of external forces, an object remains in equilibrium, at rest, or moving with constant velocity. Forces that we will be talking about are, for example, the weight, which is due to gravity, but also friction, for example, which is a contact force, because there are two surfaces in contact. The force of a spring, we will study the force of a spring. We will also study the normal force, that force that, for example, is doing my hand onto the mic upwards. That's the normal force, which would be always that we have two objects in contact, and that will be perpendicular to the surface of contact, and all of them will obey the same laws of physics. Forces exerted on an object can change the object's shape. For example, striking a tennis ball with a racket deforms the ball to some extent. Even objects we usually consider rigid and inflexible are deformed under the action of external forces. Often the deformations are permanent, as in the case of the collision between automobiles, and sometimes there is a restoration force that lets, for example, in the case of the tennis ball, lets the ball recover its original shape. In order to calculate the net force on an object, you will have several forces acting on that object. We need to add to sum the different vectors that we have. For example, in this case, we have three vectors, f1, f2, and f3. Then we need to sum the three vectors in order to calculate the net force acting on them. So we will decompose the vectors into the x and y components, and then sum all the x components together and then all the y components together, and that will give us the final vector, the net force acting on that object. The way we decompose an arbitrary vector in any arbitrary direction, always we will look at the x component and the y component by drawing perpendicular lines to the x and y axis, and then finding what is the projection of the total vector into both two x and y axis. And in order to calculate those components, we need to use some trigonometry and remember that the sine of an angle alpha is equal to the opposed angle divided by the hypotenuse, and the cosine is the contiguous side of the triangle divided by the hypotenuse.